name is Katrin Kieling. I'm the project manager of the CRM-geothermal project. I'm working at the GFZ Potsdam, the German Research Center for Geosciences. And this is, as I said, we are the coordinators of the CRM-geothermal project, which is about raw materials from geothermal fluids, occurrence, enrichment, and extraction. And I'm happy to give you a short overview of our project. I think the objectives of the project, or the challenge we are facing, is very clear. So large amounts of critical raw materials are needed for the energy and also for the digital transition. And you can see here in the figure the increase of demand in critical raw materials, for example, by the deployment of wind turbines, but also by the transition from combustion cars to electric cars. So we are going to double the demand in copper and mangan, but also include a lot of lithium, nickel, cobalt in these cars. And so the need for critical raw materials is going to increase drastically in the next years. From the project side, we already have a solution that we are proposing. So the extraction of critical raw materials from geothermal fluids. And this idea is actually based on the fact that even the very first geothermal power plant was built on the basis of a boron extraction or boron production field in Laderello in Italy. So this was kind of the birthplace of geothermal power. And in the last years, we have seen that the geothermal fluids in Europe, for example, in the Upper Rhine Valley, but also in the granites of Cornwall in the UK, include some elements, for example, lithium, which is considered as a game changer for the geothermal energy, but also really can make a significant contribution to the supply of Europe with lithium needed for the for electric vehicles. That's why we answered to a Horizon Europe call, Innovation for Responsible EU Sourcing of Primary Raw Materials, and we're able to secure an almost 8 million euro funding from the EU, the UK, and Switzerland. And the CRM-geothermal project is going to run from May 2022 to April 2026. So we are now almost half through the project. The concept that we are proposing is relatively clear. So we propose a combination of the extraction of heat or electricity and the extraction of valuable elements from geothermal fluids. We're going to produce from the deep reservoirs the hot geothermal fluid, first extract the energy or the heat in the geothermal power plant, and then transfer the fluid to an extraction facility where the critical raw materials are extracted and finally re-inject into the reservoir. And the key advantages of this process is that we are maximizing the returns on investment for the geothermal operators. We avoid any additional land use and also minimize environmental impact of mining. In our project, we have 20 partners from different European countries, EU, Switzerland, UK, but also Turkey, Iceland, and even Kenya. And we also include 19 affiliated entities. Those are the national associations of the European Federation of Geologists. And overall, we cover with this 23 countries, and research institutes, industries, small and medium enterprises, as well as several associations. The objectives I'm going to walk you through now bit by bit for our project. So the first objective is to establish an overview of the potential for raw materials in geothermal fluids. For this, we have already sampled fluids from, for example, hot springs in Africa, but also from geothermal power plants. And we are not only sampling the fluids, but also the host rock, as well as precipitates that can occur once the fluid is processed in the surface facilities. And all this data from the sample collection and then the analysis is going to be included in the CRM-geothermal fluid atlas. It will look a bit like this. This is a reflect fluid atlas, which we established in a previous project, the reflect project, where we concentrated still on the challenges of geochemical composition of the geothermal fluids for the geothermal operation, but now in the CRM project, we are more concentrating on the benefits of the geochemical composition. And this fluid atlas is going to include, as I said, the data from the sampling, but also historic data or data that we can collect from publication and reports. And compared to the Reflect Atlas, we are going to extend it, of course, to the CRM. So, and include really information on critical raw materials and extend it to the East African Rift. The second objective is to determine the source of selected CRM, their mobility, potential for sustained extraction from geothermal brines. For this, we look, for example, at the host rocks. We have a look at in which formations actually increased contents of critical raw materials are included. And as an example here, we looked at the samples from the North German Basin from the well in Großschöneberg in Germany. We selected 23 samples from all the formations which the well passed through and analyzed them for their lithium, strontium, and copper content. And now you can see that we found increased strontium, lithium, and also copper in several formations. And now in the next step, we are doing some leaching experiments to find out where how fast those elements can be leached into the geothermal brine, and also how sustainable really this extraction could be. The third objective is then to develop and optimize innovative extraction technologies for selected CRMs. We actually have a look at 6 different extraction technologies and also look a bit at different elements here. We are going to see in the next talk by Professor Di Noto from the University of Padua one of these extraction technologies in detail. And as an example, I also show here the fluid flow monitor and reactor unit that we built at GFZ. This is for adsorption technologies. So we can really here do some experiments at high pressure, high temperature, as we find them in the geothermal fluid, and check the different adsorption materials for the extraction of the critical raw materials. And then the fourth and fifth objectives are to assess the environmental, social, economic viability and foster ethical sourcing of CRMs. In this work package, we look a bit more, for example, at how to obtain the social license to operate, but also at different classification schemes, for example, at the UNFC, to really classify this combined extraction compared to traditional mining. And finally, we are going to demonstrate at a pilot site the extraction technology at the scale of a mini plant, and also evaluate the system's sustainability. Here you can see already a photo from the pilot testing or from the hydraulic testing in Cornwall in the UK. Last June, July, we did some, for example, an airlift test to determine the productivity index of the well, and also to see how productive the reservoir in itself is. And also we did some tracer testing. So we injected an inert solution into the formation and then back produced it to see the permeability of the reservoir. And with that, I would like to come already to the expected impacts of the project. So really to summarize those, we think that the combined extraction has a potential to cover a significant percentage of current and future needs of certain CRMs to the EU. And by applying this co-production approach, we will contribute to more resilient and domestic CRM supply chains for the EU, and by this reduce the imports exposed to markets and political risks. We also want to create more trustworthy and ethical supply chains for the CRMs and help to bridge the gap between societal resistance to raw materials and extraction and the increasing demand for raw materials, simply by making the the production of critical raw materials kind of invisible by really doing everything subsurface. And finally, since we increase returns on investment for the geothermal operators, this will also lead to a greater number of viable geothermal projects. And with that, I would like to thank you for your attention. And I'm looking forward to the discussion in the chat and also in the following sessions.